Hello students, good evening. So today I am going to explain about nodal analysis. So in this lecture what I am going to do, I'll provide some shortcut or trick by. So without wasting our time, we'll start the video. My name is SR Kusti and you are watching my beautiful channel Love You Science. So I'll be explaining the entire concept of nodal analysis by taking one example. So before solving that circuit, first we understand what is the objective of nodal analysis. Why should an engineer study nodal analysis? The primary aim of nodal analysis is to find out the branch current of a electrical network. So let a complex electrical circuit will be given to you. You need to find out different branch current or current through various branch or maybe potential drop across various branch. For that we have to apply nodal analysis. There are many theorems there like superposition theorem, Thevenin theorem, Norton theorem, Mesh analysis. So similarly, another theorem is there nodal analysis. So the trick are, so first point is we'll have to choose a reference node and we have to consider the potential at this node is higher as compared to other potential, or the potential at the node or junction is dominating over other potential. And second point is we'll have to apply KCL on that node. And one important trick you should remember, we have to consider the current will be outward. And the third point is if we have different voltage source or maybe current source in that circuit, to know the sign of that voltage source or current source we have to apply these two trick. The first one is if there is a voltage source of magnitude V is given, if this is our direction, this is our direction what we assume, that means we are going from negative potential to positive potential. So here it will be rise in potential and the sign of voltage will be positive and reverse will be negative. Reverse matlab kya hai? This is our direction which we assume, that is the direction of current what we assume, and this is a potential difference or voltage source of magnitude V is given. So here we are going from positive potential to negative potential. So it means it will be fall in potential and the sign of voltage will be considered as negative. Similarly, if we have current source of magnitude I and that is direction of current which is given in the circuit and this is our direction what we assume, if both the direction are matching, so the sign of current will be taken as positive. Similarly, reverse will be negative. Reverse matlab kya hai? If current direction is from left to right, which is given in the circuit, and if our assumption is against to that or opposite to that, it will be considered as negative. So by taking this example, again I will explain the entire part and will write the equation and solve the question. So first point kya hai? First point is we have to consider a reference node. So let us, this one is a node, इसका नाम दे दो A and the potential at A is let it be VA. Got my point? The first point is we have to consider a reference node. So let this is a node. And what is node, what is mesh, what is junction already I have explained in my previous video. So let us, this one is a node of potential VA and the potential at this point will be higher as compared to other potentials. So in this circuit there are two other potential, two voltage source having magnitude 35 volt and 40 volt. So we have to assume that the potential at VA is dominating over other two potential, or the potential at VA, the potential at A which is VA is higher than these two potential. Clear? Next we will apply KCL and the current direction would be outward. That is our assumption. Let this current is I1 which is coming out from the junction and this one is I2 and this one is I3. But actually this is not the direction of current. We will find out the answer. We will verify it whether our assumption is right or wrong. So let us, there are three branch current are coming from this node. Since we have assumed this potential at A is dominating over other potential, then we'll apply KCL. KCL क्या होता है? The sum of current meeting at a point is 0. So in this junction, I can write down I1 plus I2 plus I3 will be 0 as per the KCL is concerned. So in place of I1, I can write down VA minus of 35 upon 3. Why? Because VA, and we are going from this point, this is the direction of current what we assume, and we are going from positive terminal to negative terminal. Positive terminal to negative terminal. What is the sign of that voltage? Negative. That's why it is VA minus of 35 change in voltage upon resistance 3, which will be I1. Similarly, for I2, what I can write? VA, what is the branch current? Voltage upon resistance, what is the voltage? VA, and this one is 0 by 2 ohm. Plus, what about I3? VA, what is the change in potential in this branch? VA minus 40. Why it is minus 40? Because this is the direction of current what you assume, and it is going from positive terminal to negative terminal. It will be fall in potential. The sign of V will be negative. So it will be what? Minus 40 upon how much? 4, which will be equal to 0. Done. Answer हो गया. देखो, now it is very simple. You can take the LCM. LCM क्या है? LCM let it be 12, and it is 4VA minus of how much? 140, right? Plus 6VA plus 3VA minus 120 will be 0, right? So 4VA plus 6VA plus 3VA will be 13VA, and 140 minus of 120, it will be minus of 260. That if it is going to that side, it will be 2 plus 260, right? So what is VA? VA is coming, I think, 20 volt. Done. So now we can easily get the answer. Our objective is to find out branch current like I1, I2, I3 कितना है. See, VA is 20 volt. यहाँ पे 20 डाल दो, हो जाएगा क्या है? I1. And इसमें देखो, for I2 only 20 by 2, which will be 10, and for I3 it will be 20 minus 40 upon 4. Okay, answer. Okay, we'll find out the answer, right? So VA is coming how much? VA is coming 20 volt. ठीक है? So I erase this part. Okay, यहाँ पे डाल दो to find out I1. I1 कितना हो जाएगा? VA. VA कितना है? 20 minus of 35 upon 3. So it is coming minus 15 upon 3, that is minus 5 ampere. Done. And similarly for I2, I2 क्या है? VA upon 2. VA कितना है हमारा? 20. 20 upon 2 is 10 ampere. ठीक है? And for I3, like for I3 VA कितना है? 20 minus 40 upon 4. So it is minus 20 upon 4 is minus of 5 ampere. Now we are getting the answer. I1 is minus 5, I3 is minus 5, and I2 is plus 10. यहाँ पे चेक करो, minus 5 plus 10 minus 5 कितना हो गया? 0. So what will be your final answer? मतलब ये जो actual current direction is from left to right, because we assume that current is coming from that point, but while solving we are getting current as minus 5. मतलब actual current is 5 ampere towards the junction. Similarly for I2 is coming 10. So our assumption, it was, we have taken as positive, and we are also getting current as positive. So our assumption is true. मतलब ये current सही है. ये current कितना है? I2 10. So ये I1 कितना है? 5. The actual direction of current I1 is 5. And what about I3? Actually we have taken I3 as positive, but we are getting I3 as minus 5. मतलब our assumption is wrong. Actual current direction is from right to left, which is 5 एम्पियर। चेक करो यहाँ देखो 5 एम्पियर current is flowing up to this point or towards the junction. Here 5 एम्पियर current is flowing towards the junction. Net current will be 10 and that 10 एम्पियर current is flowing from the junction. Okay, we'll go to the next questions. So we'll solve the circuit by using nodal analysis. So that means we'll find out the branch current by using nodal analysis in the circuit. So we have a circuit of two sources having potential difference of 35 volt and 40 volts are connected. Here the sign of potential difference is like that. It is plus and minus and it is minus and plus. So in previous question, I have taken plus minus, here also have taken plus minus. But now what I did, I have keep that sign as it was in the circuit, but I changed that. Okay. So how to solve this one? So first point is we have to consider a node. So this point is node and the potential at the point is VA, which is higher as compared to other potential. So next we'll apply KCL and our assumption would be current outward. Let so with respect to this point there are three branches. Branch 1 current I1, branch 2 current is I2 and branch 3 current is I3, right? So if we'll apply KCL, so I can write down I1 plus I2 plus I3 will be 0. So in place of I1 I can write down VA minus of 35 volt. Why it is minus 35 volt? Already I have explained. The current direction is from that point. It was our assumption. That means we are going from higher potential to lower potential. The potential or the voltage will be taken as negative. So what is the change in potential here? VA minus of 35. And what is the resistance? That is 3. So total part will be current I1 plus. Next, what about I2? What is the change in potential here? VA minus of 0 upon what is the resistance? 2 plus. What about I3? I3 is VA. Next, we are going from this point. That means we are going from lower potential to higher potential. So this sign would be positive. See, this one is positive. So what is the change in potential here? VA plus of 40 upon what is the resistance? 4 will be equal to 0. Then you can solve this equation. You can get the value of VA. Then you can put here, you can get I1, you put here, you can get I2, you put here, you can get I3. Done. इतना तो करना है, ठीक है? Okay. Let us find the answer. 3, 2, 6. What is the LCM? Let it 2. Okay. Sorry, 12. Sorry. 12. 12, 3, 4. So 4 VA minus of 140 plus of 6 VA. Okay, plus of 3 VA. Then plus of 120 will be 0. So I can write down 4 VA, 6 VA, 3 VA. It will be 13 VA minus 140 plus 120. It will be minus 20. Then it is coming to that side will be plus 20, right? So what is VA? Which is 20 upon 13. So VA is coming 20 upon 13. What is the value of 20 upon 13? I think 1 point. Okay, I have the calculator. I can calculate here. 20 upon 30. 20 upon 13. So it is coming 1.54 approx. 1.54 volt. Okay. So finally we are getting voltage. Potential at this point is 1. VA is we are getting 1.54 volt. Then next we'll find out the branch current. See, to find out IA we can put here. So I1 कितना हो जाएगा? VA is 1.54 minus of 35 upon 3. Okay. Similarly for I2 कितना होगा? VA is 1.54 upon 2. ठीक है. And for I3 what will be your answer? VA is 1.54 plus 40 upon 4, right? So it is coming 41.54 upon 4. So final answer will get 1.54 minus of 35. I have the calculator. You can use 1.54 minus of 35, okay, by 3. It is coming minus of 11.15. ठीक है, ये हो गया आपका I1 and I2 1.54 by 2. So 1.54 by 2, it is coming 0.77. And for this one I3 41.54 by 4, so it is coming 10.38. See, I1, I2, I3 we are getting. So I1 is minus of 11.15. That means our assumption is wrong. Actually current is flowing from left to right. And बाकी दो वैल्यू क्या मिला, पॉजिटिव मिला, मतलब our assumption is right. See, sum of these two current will be equal to this current. That is called KCL, na? Sum of incoming current will be equal to sum of outgoing current. Okay, next we have this question. So in this circuit, we have two source, one voltage source, one current source. The magnitude of voltage source is 20 volt and magnitude of current source is 5 ohm. There are three resistors. This is the electrical circuit. We have to find out branch current or current through various branches, 2 ohm, 3 ohm, 4 ohm. Okay, we apply nodal analysis to solve that circuit or to analyze that circuit. So what I have told you, so the first point is we have to find the reference node and the potential at this node will be higher as compared to other potential or other sources. So here this is a node, इसका नाम दे दो VA and the potential at A is higher as compared to other potential. मतलब the potential at VA is higher than this one, the potential at VA is higher as compared to also the effect of current source, right? So we next is we'll apply KCL. What is KCL? The sum of current meeting at the point is 0. So from with respect to that node, there are how many branches? Branch 1, let this current is I1, and branch 2, let this current is I2, and branch 3, let this current is I3. So if I apply KCL, so I can write down I1 plus I2 plus I3 will be 0. Okay, so in place of I1, what I can write, what is the change in potential over here? VA minus of 20, because we are coming from this point and it will be falling potential since we are coming from higher potential to lower potential. So the change in potential will be VA and the sign of this voltage will be minus. So it is VA minus 20 upon what is the resistance? 2 plus. Here what is the change in potential? This is VA minus of 0 upon what is the resistance? 4. Next is, what about I3? So for I3, no need to take the potential difference. Already one current source is given. So that means 5 ampere of current is flowing towards this point as per the question. In the question it is given itself, the current is of 5 ampere magnitude is coming towards the node. But what is our assumption? The current we have taken, what is our assumption? It is outward. So that means the direction of the current which is given in the circuit is opposite to our assumption current. So we'll apply this one. The direction of current is from right to left, but the current what we assume it is from left to right. So it is opposite to that. So the sign of the current source will be negative. मतलब directly you can write down 5. No need to take the potential difference. No need to take that resistance because already current is given. So it is, so the value of I3 is minus 5. Then you can solve this one to get the value of VA. Okay. So after getting the value of VA, you can put here to find out I1 and I2. Okay, let me solve 2 and 4. Like LCM is, I think 4. So it will be 2VA minus of 40 plus of VA. Okay, so plus of VA will be equal to how much? 5. ठीक है, सो ये अगर मल्टीप्लाई हो जाएगा कितना हो जाएगा? 5 4 जा 20, so it will be 20. So 2VA VA, it is 3VA will be equal to 60. So what is VA? VA is 20 volt. ठीक है, that means we are getting VA as 20 volt. Now what we'll do, we put the value of VA here, we can get I1. ठीक है, so VA कितना है? 20. So to find out I1, I1 will be 20 minus of 20 upon 2. So I1 will be 0. And similarly to find out I2, we put here I2 will be VA कितना है? 20 upon 4. It is coming 5 ampere. ठीक है, ये हो गया I2. And I3 is already given. I3 कितना है? 5 ampere minus of. That means your final answer will be current through this branch will be 0 and the current through this branch is 5, which is correct, and the current through this branch is minus 5 if we consider current from left to right, but actually current is flowing from right to left. Okay, so in the same question, if I change the polarity of the current source, then what will be our answer? So let us solve. If I change the polarity, let the polarity is downward. Okay, so see, same thing. First we consider a node. This point is A and potential at A is dominating over other potential or higher as compared to other potential. And looking from that point, there are 3 branches of current I1, I2 and I3. We have to take, that is our assumption. Then we'll apply KCL. What is KCL? The sum of current would be 0. ठीक है, so I1 क्या हो जाएगा? Same thing, VA minus of 20 upon 2 plus what is I2? VA minus of 0 upon 4. And for I3, see, actually current is coming from the junction. Since source is connected, I have changed the polarity. And the current which we assume, it is also coming from the junction. So our assumption current is same as the current which is given in the source or the direction of current. So दोनों का direction same है. So मतलब it is taken as positive. The magnitude will be plus 5 is equal to 0. Then we can solve it and we can get the value of VA. Then if we put here in this part, we can get I1. Similarly, in this part, we can get I2. And I3 is already given plus 5. Okay, let's solve this one to check it whether our assumption is correct or not. LCM कितना है? 8. No. 4 2. It will be 2VA minus of 40 plus 10VA, I think. Sorry, not 10VA, VA. Okay, so it will be minus of 5. 4 multiply हो जाएगा तो कितना हो जाएगा? Minus of 20. ठीक है, so let me erase. 2VA plus VA is 3VA and 40 minus 20 is plus 20. ठीक है, so VA is coming 20 upon 3, which is 6.66 volt. So that means we are getting VA as 6.66 volt. ठीक है, then to find out I1, what we'll do? To find out I1, what we'll do? We put here. So VA कितना है? 6.66 minus of 20 upon 2. So it is coming. Okay, 6.66 minus 20. I have the calculator. I'll use that. Okay, 6.66 minus of 20 is coming minus 13.34 upon 2, it is coming minus 6.67. ठीक है, एंड सिमिलरली आई टू यहाँ पे डाल दो, इसका वैल्यू वैल्यू कितना है 6.66 अपॉन 4, सो इट इज कमिंग 6.66 अपॉन 4 1.66. ठीक है, एंड व्हाट इज आई थ्री इज 5. सो ठीक है ना, ये देखो ये माइनस 6.67, ये प्लस 1.6, लेट इट बी 6.6 1.66. ठीक है, सम ऑफ दिस टू करंट इज 5 एंड इट इज 5. ठीक है, सो मतलब एक्चुअल द करंट डायरेक्शन is from left to right, which was 6.67 ampere, and for I2 it is okay. I2 का डायरेक्शन क्या है, सेम है, कितना होगा 1.66, and this current is 5. This current is 5. The potential at A is higher as compared to other potential. So if we'll apply KCL, so looking from the point A, there are three branches. Branch 1, let this current is I1. Branch 2, let this current is I2. And branch 3, let this current is I3. And you apply KCL, so I can write down I1 plus I2 plus I3 will be 0. So in place of I1, I can write down VA minus of 100 volt. Why it is minus? Because we are going from positive terminal to negative terminal falling potential. Many times I have told you. So in place of I1, I can write down change in potential is VA upon, so VA minus 100 upon 20, plus in place of I2, I can write down VA minus of 0 upon 10, plus in place of I3, what is the change in potential? VA minus VB. Why? Because we are considering this point as our reference point or reference node. That means the potential at the point is higher as compared to other potential. It may be VB or it may be V 100 volt, it may be anything. So it will be VA minus of VB upon 15 will be equal to 0. Okay. So ये हो गया आपका equation number 1. So you can solve this equation. 13 VA and 3 VA 6 VA कितना 9 VA plus 4 13 VA minus of 4 VB will be equal to 300. So ये हो गया equation number 1. Similarly, we can apply KCL at this node VB, at this node B. So looking from the node B, there are three branches, branch 1, branch 2, branch 3. Let this current is I3 dash, and this current is I4, and this current is I5. You can take anything. We have taken I3 dash because answer तो same ही मिलेगा. So ये I3 dash, this one is I4, this one is I5. So मतलब ये क्या हो जाएगा I3 dash, ये I4, ये क्या है I5. Then see next, what about I3 dash? VB minus of VA, VB minus of VA upon 15 plus I4 क्या है VB minus of 0 upon 10 plus I5 क्या है VB plus of 80, because we are going from negative potential to positive potential, rising potential. So VB plus of 80 upon 10 will be equal to 0. So if you take LCM, okay, ये इक्वेशन याद रखना, ठीक है, बाद में सी आई एम राइटिंग हियर 13 VA minus of 4 VB will be equal to 300. ये हो गया हमारा इक्वेशन नंबर 1. So I can erase this part. Okay, so what is the LCM? 30, so it is 2 VB minus of 2 VA plus of 3 VB plus of 3 VB. ठीक है, then plus of 80 नहीं, plus of 240 will be equal to 0. So 30 तो मल्टीप्लाई हो जाएगा, छोड़ दो, ओके, इट विल बी 0। सो इसमें देखो 2 VB 3 VB 5 VB प्लस 3 8। So 8 VB minus 2 VA. Okay, first I'm writing minus 2 VA plus 8 VB will be equal to minus 240, right? So, or I can write down plus 2 VA minus of 8 VB will be equal to 240. Okay, then 2 divide कर लो, so it will be VA minus of 4 VB will be equal to 120. ठीक है, ये हो गया इक्वेशन नंबर 2. So see, we have two equation, two unknown variable VA and VB. We can get the answer. We have two equation, equation 1, equation 2. We have two unknown parameter VA and VB. So by using that two equation, you can get the value of VA and VB. I think VA is coming 15 volt. VA is coming 15 volt and VB is coming minus 26, minus 26.25 volt. So I1, I2, I3, here I3 dash, I4, I5. We have the equation, you can put the value of VA, VB in this previous equation, you can get the answer. So I have solved this question, I got the answer. फिर भी तुम लोग ट्राई करो, कंपेयर करो, चेक करो, देखो सेम आ रहा है कि नहीं. ठीक है, so I have the answer. So I1 is coming minus 4.25 ampere. एक बार चेक करना, ठीक है. And I2 is coming 1.5 ampere, I3 is 2.75 ampere, I3 dash is minus 2.75 ampere, I4 is minus 2.625 ampere, and I5 is 5.375 ampere. ठीक है, so don't worry about the calculation तो easy है, so I don't want to waste time, so I already have calculated it, that's why I wrote here. So calculator will be provided in semester examination, don't worry about it, but the main important point is कि you should remember how to apply KCL in that junction, and most important part is you should remember these three things. The first one is reference node, you have to consider the potential at this point is dominating over other potential. Second point is you have to apply KCL on that node and keep in mind that potential is higher. You will apply KCL like sum of current will be 0 and current का direction जो है you have to assume it will be outward. And next is if you have different sources in that circuit, so if you are going from negative terminal to positive terminal of a potential of a source having potential V, so it will be considered as positive, and if it is from plus to minus it will be considered as negative. And similarly, if you have current source having sign, the sign of current in the current source is given in that question, and if your assumption is match with the direction of current, then it will be taken as positive, and if your direction assumption direction is opposite to that direction of current which is given in the question, then it will be taken as negative. ठीक है, इतना ही just याद रखना. Okay, I hope you understood what I have explained today. So with this I am ending this lecture. So thank you so much for watching this video. If you like my video, please do subscribe and share. Thank you all.